Hi all, this is Priyadharshini working as an assistant professor in the Department of Artificial Intelligence and Data Science. Today we are going to continue with the topic process concept. Now we are going to see about the process scheduling. So we'll see what is the definition of a process scheduling. The process scheduling is the activity of the process manager that handles the removal of the running process from the CPU and the selection of another process on the basis of a particular strategy. So taking out the running process from the CPU and allocating a new process to the processor is called as process scheduling. So the module of operating system that makes this decision is called the scheduler. So in scheduling, we have three types of scheduling queues. So scheduling queues refers to the queues of process or devices. So there are three queues available. So first one is job queue, next one is ready queue, and the final one is device queue. Whenever the process enters the system, then this process is put into a job queue. This queue consists of all the processes in the system. That is, whenever a process enters the system, that is from the secondary memory to the main memory, so all those processes will be available in the job queue. The next queue is called the ready queue. So here the processes that are residing in main memory, that is the process which is from secondary memory to main memory, will be available in the job queue. In the ready queue, the processes that are in main memory which are ready and waiting for the processor will be kept in the queue called the ready queue. So the processes that are residing in main memory and are ready and waiting to execute are kept on a list called the ready queue. This queue is generally stored as a linked list. And the other type of queue is called the device queue. Here the operating system also maintains other queue such as device queue, which is a queue for which multiple processes are waiting for a particular input-output device. So in scheduling, we have three types of queues available: job queue, ready queue, device queue. So job queue, secondary to main memory; ready queue, from main memory waiting for the processor. Device queue consists of all the input-output devices used for the particular process. So always in the process, the ready queue and device queue will be taken place. So this is the representation of a process scheduling. So first, the process is available from the job queue, is taken into the ready queue, that is, it has been loaded into the main memory, and from ready queue the process is waiting, and whenever the scheduler dispatches the process to the processor, then the process executes smoothly. So it will be going to the terminated condition. Otherwise, there are different types occur. So first thing is, when the process is in the processor, if the process needs some input output for a particular process to run, then it goes to the device queue, that is input output request. So it goes to the input output queue and executes the input output operations needed, and then it will be sent to the ready queue again for execution. Or else, if it is a time sharing system, then if the time slice has expired, then again that process will be sent to the ready queue for further execution. Suppose if there is a system called a fork. So if there is a fork system call, then particular process will create, or it waits for the child to execute. So child is executed. After the child completes its execution, again this process will be put inside the ready queue. Or else the final thing would be, if there is some interrupt, that is, if the operating system is coming with a high priority process, then the running process has to put into the waiting queue. So it waits for an interrupt, and if the interrupt finishes, again the process will be taken to the ready queue, and from there it will be dispatched to the processor for execution. So these are the representation of process scheduling. So let us have deep look into this. A common representation of process scheduling is what we saw as a queuing diagram. So in this queuing diagram, we have represented queues as the rectangular box. So can you see input output queue? So these are input output requests. If there is a fork, if there is an interrupt, ready queue, job queue, those all are represented as a rectangular box. The circles represent the resources that serve the queues. The arrows indicates the process flow in the system. So queues are of two types, ready queue and device queue. So when a newly arrived process is put in the ready queue, process wait in a ready queue for allocating the CPU. Once the CPU is assigned to a process, then the process will execute. While executing the process, any of the following events can occur. So process could issue an IO request, or it could create new sub-processes, or it could be removed forcibly from the CPU as a result of interrupt. So after this, they are all put back in the ready queue. So there is two-state process model which refers to the running and non-running states, which are described as below. So running state, when new process is created by the operating system, then the process enters into the system as its running state. The processes that are not running are kept in the queue waiting for their turn to execute, or called non-running state. So as we saw process in the process scheduling, we saw three queues. Also we have schedulers. So these schedulers are special systemwares which handles process scheduling in various ways. So there are three types of schedulers: long-term scheduler, short-term scheduler, medium-term scheduler. So long-term scheduler is nothing but it is can also be called as job scheduler. So it determines which program should be admitted to the system for processing. Also it selects process from the queue and loads them into memory for execution. So it also controls the degree of multiprogramming. Short-term scheduler is otherwise called as CPU scheduler. So it selects from among the processes that are ready to execute and allocate the CPU for one of them. So the short-term scheduler must select a new process for the CPU frequently. This scheduler should be very fast because of the short time between executions of the process. And finally we have medium-term scheduler. So medium-term scheduler removes a process from my memory and stores it into the secondary storage. After some time, the process can be reintroduced into main memory and execution can be continued where it left off. This is called as swapping in and swapping out process. So the medium-term scheduler moves a process from CPU to input-output waiting queue and input-output queue to ready queue. So these are the different types of schedulers available.